Yeah, hi. I think mock is released, right? No, there is no mock.
No, sir, it is not
No
released.
more.
Okay, there is no mock. Let me ask. Okay, so it will be released. Maybe still it should be released by today, but I don't know why it is not. Okay, so this is the first revision session for MLF. Yes, so we'll try to discuss the questions. Okay, and I have some old question last time quiz one questions I will try to discuss today. Okay, and also we'll discuss some some quick revision of week 1 and 2. I just very quick revision. Maybe I will give the formulas, and probably I will take doubts. If you have any kind of doubt, please let me know. I will discuss. So in this first session, try to cover week 1 and 2. So yes, so they have some doubt.
Sir, could you please explain the week-wise coverage? What will be the marks cover week-wise?
Yeah, I have some slide with me. So according to that, I will proceed. Yeah, Aditi want to say something? Yes.
Sir, I am confused about column space, row space, and null space and left null space. If possible, sir, please take that topic also.
Okay.
Sir, same
Thank
doubt.
you, sir.
Null space, column space.
Yes,
Okay.
sir.
Okay. Some square will try to cover in the next. So these topics are of week 3 and 4. Yeah, maybe if you have many of you have doubt in the 4 fundamental spaces, I will just try to discuss that concept only. So today's session will try to cover the concept whatever will be in week 1 and 2. Okay, and we will see the questions related to that. Saturday will be the next revision session. On that day, we'll discuss 3 and 4. Okay, so let me present my screen.
Sir, the questions will be similar to the graded assignments, right?
So it would be similar, but yeah, I will suggest you to see the old question papers. Okay, that would be helpful for you to understand. If you know the concept, then I am sure that you will not find difficulty to solve the problems. Okay, if you know the concepts only.
Sir, from where can we access that PIQs?
So yeah, I will tell you that which topics are more important. I will not keep I will just say kind of you can emphasis on these topics only. So okay, while discussing, I will discuss. I will
Hello,
tell you
sir.
which topics will be more
Sir,
important.
am I audible?
Yes, you are audible. Yes, Aditya.
Sir, is this session for week 1 and 2, or
Week
I can
week
ask something from week 4?
week 1 and 2, but once it will be finished, then I will take your doubts. If you have 3 and from 3 and 4, when I will take those. I will try to take those
Okay, sir.
doubts. Okay.
Thank you, sir.
Okay. So So let me go with whatever I have prepared something. Just quick revision. I will try to do that. Whatever things in week 1. So as you know, this is a machine learning foundation. So foundation means is it is a built it. We'll try to discuss. So foundation is more as you have seen the more mathematical tools we'll see more on algebra only and optimization. A bit about the statistics also. So data is generally we know the collection of data. And already in maths 2 you have seen that a vector representation. So you have suppose house price generally if there is a area and you just collected the data of there is a area and where or colony where the rooms are some data related to the particular houses that it is from this much distance from the station. So and this is the price and maybe how many rooms are there, how many mm, uh, many more information. So if you just collect in a set of uh, houses and if you collect those all in a kind of row, would all of you check that mock is released, I think.
No, sir.
Mama, what?
No, sir. Mock is not released.
From our side is saying okay, from upstream it is saying that it is released already.
So there is no mock yet.
Okay. It will be
Sir,
released.
just now I joined.
It will be released.
Any important topics I missed?
No, nothing. I just now I started. And I started the first word, the data here. So data is a collection of uh, uh, some it will contain a data is this columns represent the distance from from station. This column represent the how many rooms are particular the particular house. So it's represented, it will represent as a column y. So vector as a vector generally data is set of vectors you can think. So model is already, what is a model is you have some information, we'll try to convert in some mathematical uh, in some mathematical expression. That is that is a model. So ML task is just a task. We'll try to how we'll solve that problem. So what is here will what is a machine learning then now is that we'll have some data and using those data we'll try to build a model and we'll try to perform some set of tasks. And so how we'll build that model? So it is based on some models are generally content. So models are mathematical operations, some mathematical expressions should be. So here are some kind of supervised learning and unsupervised learning. There are, so these two type of learning is there, supervised learning and unsupervised learning. So hope all of you know already these are what is the supervised learning and unsupervised learning. Mostly supervised learning is a kind of curve fitting where we'll try to fit some curve, and unsupervised learning is totally as we have seen kind of predicting or not predicting. Even somebody have tweeted something and there is a already in there is a robot bot generally it call it generally tweet also. So what is the, so you will create a model which will recognize that a person is somebody has tweeted. So what is the probability that this Twitter is that that tweet is very similar to whatever some particular person have tweeted. So it is actually kind of recognition. Here is the question would be a kind of solving the problem. So based on this supervised learning, unsupervised learning, there is one problem. It would be more clear when we'll see a problem related to this like this. This is an old question paper, and this problem is there. Could you all of you try this? And which of the following is our supervised learning task? There are 4 options. First option is predicting the future sales of product based on the past sales data, and second one is reducing the dimensity dimensity of image while retaining the essential features. And the next thing is the recognizing and interpreting handwritten character or words, and often used in the digital recognition and reading handwritten text. Next is categorizing text document into some predefined classes. So which option is going to do? Could all of you
ACD.
try?
Sir, A and D.
ACD. Why B is not?
Because it is dimensionality reduction.
Yes, sir, or dimension reduction.
It's unsupervised learning.
Dimensity reduction. So already, even if you just see the here, if you know what is that, this one from here itself, unsupervised learning is dimensity reduction and density estimation, and supervised learnings are majorly we'll study supervised learning is regression and classification.
Option
Yes.
C is similar to density estimation, I think.
Yes, sir. That also seems like unsupervised learning.
Which one?
Option C.
Option C is
Option C.
Recognizing handwriting letters.
yes, recognizing and interpreting handwritten characters or words. So it is already, yeah, it is a supervised learning, right?
Yes, it comes under
It
classification.
will just yeah, it will come under the, somebody is saying something. Okay. Just yeah, Krishna.
Sir, C little bit unclear, sir.
C is not clear. So it is just recognizing, means it would be a kind of classification, right? So if suppose some sentence is written, so suppose some set of there are suppose this sentence is written and you have already some set of classes, and you want to recognize that, means these are you have already, right? You want to recognize, is this handwritten, in which part it will fall, correct? That's the meaning here, recognizing. You have already some set of where you have some set of mean to say like or what is, for example, let's say you have in this set, or even let's say what is that, in this class, a kind of class, generally, for example, I am saying, let's say in this class A to D is there, and D to, in this class D to C, whatever H is there, and other class, other character will fall here. So I just give an example. So you have some sentence and you want to recognize in which part it will fall, it will lie, in which group. So it would be a kind of classification, right? So classification is already a supervised learning. And here is dimensity, here is reduction. The dimensity is already given. So dimensity reduction is in the unsupervised learning. So that's why this B part is going to be wrong. The correct options are A, C, and D. Okay.
Sir,
Yes.
by recognizing it means that it already has learned the characters. It is just again remembering it. That's what it recognizing mean here.
Recognize means you have already, you want to, you have already something is there and you want to just, is this part is similar to that one which you have already.
Okay.
That's the meaning here.
Sir, unsupervised
how
learning comes under
different-
predictive model or probabilistic model?
Sorry.
I was asking that unsupervised learning comes under predictive model or probabilistic model?
So unsupervised learning is generally, in the probabilistic model.
Okay.
Okay. It will be give the probability that how much it would be. And the next is, anybody want to say something?
Excuse me, sir.
Yes.
Yes, sir. Sir, I was asking that how option C is different from um, estimating seconds on supervised learning. Sir, I could not remember that.
Density estimation.
Yes, sir. Density estimation.
So in density estimation is, it will give the probability, right? Here is the recognition. It is not giving the probability that it would be of that this is the probability that, or this much probability to be familiar to that part. Density estimation is give the probability how much that tweet is, how to be, that how much that tweet is similar to that whatever already you have. But here is what
Okay, sir.
recognition is there. You have already some characters, you have to recognize that whatever some sentence is given. That's the
Yes, sir. Sir, correct me if I am wrong. Sir, classification is like deciding something that it is A or B out of given items, and
Yes.
density estimation is like out of these, what is the probability that this item belongs to a particular type.
Correct.
Am I correct, sir?
Yes, correct.
Okay,
That's
thank you, sir.
Jackie, you want to say something?
Sir, which year PYQ is this?
This is the last Jan term. This is of the Jan term. Okay, so let's move ahead, and next is supervised learning is just, you'll play on the real time and just a kind of curve fitting is there. And this one is that now in supervised learning there is regression. And what is a regression is that?
So the output
Regression
will always
is,
be real valued.
yes, output is going to be a real value.
So regression is supervised.
Yeah, regression is supervised learning. Regression and classification are two supervised learning. This one. And dimensity reduction and density estimation is unsupervised learning. Okay. So what is the regression? Regression is you have some set of data. Okay. And you have some training data. So let's say that's why I just already taken. No, there is no example I've taken. So what is the regression is that you have some training data. So let's say x1. Okay, here is x1 is belongs to some set of, some particular dimension. Let's say r1, r2, r3. Okay, just if anybody want to ask something, just unmute yourself and ask. That would be good for me. Otherwise I will try to see here many times. Okay. So regression is going to be, you have some set of data. Okay, so here is x1, or in superscript x1, x2. So x1, it would be of, as it is going to be a vector, it will represent a vector. So this is x1, this is x2, this is x3. Okay, this is going to be a vector, maybe from whatever the dimension we are, like how many rows are there, like r4, 4 rows are there, or so that means it is from r4 or r3. Okay, so you have some set of data. Okay, and we'll try to build, using those set of data, we'll try to build a model, and model would be, of this kind. Model would be of this kind, where the variable, this is your variable, this is going to be your set of values here will substitute. So this is going to be a linear, this tells you there is no degree, this is not a square, this is not cube, this is just a 1 degree. So that's why linear means it is going to be a, see that this is a linear parameterization, where you will substitute the set of data value. So here is this is going to be your model. Model is generally a set of expression, right? A mathematical expression. So this is a mathematical expression we have. This is a model we have, and using these data, we'll try to predict something. So like here, the predicting the house price. Okay, predicting the house price. Okay, you have some house. I want to predict some house, a price of the house, and the features are, area, distance, number of rooms. This will be the features. Okay, and loss. So this is one model. Okay, this suppose this is one model. Maybe there would be a second model. There may be a third model. Okay, there would be some set of models. Okay, and which model give the less loss. So this loss would be calculated by this formula.
Sir, in this fx is equals to w transpose x plus b. What is b here?
B is here,
Sir,
so
bias.
This is bias. Yeah, so this is added, from weight or something is added here. Or let's say generally this part, let's say for example, I am just giving a model, that fx is equal to, let's say 2x, and this part 3. So this b part is, generally in a representing a line or some square error, if you remember. So that b part, that constant. So this tells you that weight or something is added here, that this will be constant for each time. As this part is, some weight is added there. That's the meaning here. Okay. So it will be itself in the function, that model. Okay.
Got
so
it,
I
sir.
think I have one problem on this. Let me check from the old question paper. No, it is on encoder and decoder. Okay. So maybe we'll discuss, or already, in the lecture itself, very clearly sir is explaining what is the regression, how we'll proceed in the regression. And now this is the classification part. Classification is again, it will be, you know, a kind of, you have some set of data, okay, and you have some model F. The model is here, this, the same regression, but with the sign, whatever the output. So for example, here it is, you have some set of data, no? So this is, you have some set of data, and this y value, this output is already, you know, you have and so this y value is already, we have that, okay, this, for this particular, that we have, we are actually, what it means that we are actually, this is called training data, okay, these all, you have to see that these are training data. We are actually try to train our model, how much our model is actually fit or good with respect to this training data. So using this training data, we'll try to build a model. So this one as here, okay. And so these are the outputs we have already. And now whatever we model we have created here, so let's calculate the each time function value. Means here is the sign, this is just a sign, and let's say this is where is that, suppose this is one model, fx is equal to sine of 2x1. x1 is, so this is your x1 and this is your x2 each time. For each, this is going to be your x1 and this is x2. We have separate, we can separate it here, okay. Now fx is, we can calculate 2 minus x1 each time, and whatever we'll get, if it is going to be positive, we'll just write +1. If it is going to be negative, then we are going to write -1. So here is what is the classification is, either plus group and there is minus group. There is two classification is there. Either our this data, this one is going to be fall plus side, or this one is going to be fall in this second group. That's the meaning here, this one each time. So now we'll just substitute here and calculate the sign. So we can see it here. If for this one we have +1, for this one is +1, and for this one is -1 -1. So these are the two groups we got. So this is for first model, and similarly we have another model G, and here it uses both x1 and x2, and whatever the sign will get, we'll just try to categorize. It will follow, or it will be in the +1, or it will going to be a -1. So each time here, this is just substituting these are just substituting the values. 0 minus 2 times 0. So here is the first one calculated at 0 minus 2 times 0, which is 0. Okay, 0 is +1 generally.
So why 0 is considered +1?
Because if there is no sign is there, we'll generally think it as a positive. Okay, generally we'll think 0 as a positive one. There is no sign, but
so then there is one miscalculation when we are considering +1.
Sorry.
There will be one classification if we are considering 0 as plus or +1.
So generally 0 as a +1, right? There is no
Sir,
sign.
I have one doubt.
Yes.
Will it not affect in long models, sir? If so many zeros are coming and we are considering it as +1, so will it not affect the model?
It may affect, so it's depend on, like, so this is one example, right? This is not any real-time model. This is just an example.
Okay, sir.
Somebody want to say something? Yeah.
One doubt.
Yeah, what is the doubt?
Sir, in one of the GA questions, there was a question about the loss function.
Your voice is breaking.
+1 or 1?
Your voice is breaking a lot.
So we have fx and gx. How do we
Audible
find
now?
the yx?
Sorry.
We are given the fx and gx functions, right? What's the function for yx, or do we use fx and gx for finding yx?
Calculating the error. Only just calculating the error.
Sir, am I audible now?
Yeah, you are audible now, Aditya.
Yes, sir. Sir, I was asking that in one of the GA question, there was a question about plus one and minus one are the classification model Y. So, sir, if zero is coming, why should we consider it as plus one? Why it is not a loss function?
So that is what I said, right? Generally, we'll think as no zero as a plus sign is there. Generally, we think zero as a plus, positive. For zero, there is no sign, right? Left side is negative sign, right side is positive. But generally, we think zero as a positive one.
Okay, sir.
So,
Yes.
I want to clarify one thing. If it's a positive number, let's say +2, then we will take as +1.
+1 only, yes. That's the classification. There are two groups. A positive value you are getting, it will be fall in the positive group, +1 side. And if it is negative sign you are getting, then it will be fall in the negative. This one, -1.
Okay, sir.
And what is the, so somebody says, what is the use of this Y? This one. So here we can see, right? If it is the plus, then suppose you so here we can see now if you try to calculate the loss now, so these two models we have F and G, and we have calculated here the outputs. Okay, now if you see here that, so how this loss is calculated here, if output is exactly equal to that we have, because this is a training data, right? So we have already for each data we have some output already we have, and we are actually training our model. We'll try to give some function and we'll see that how much it is good or not. So we are actually training our data. So sorry, or training or this model. So what is here, if it is same exactly Y, +1 is here and +1 is here, then what is going to be this one? What is the value of this bolded one? If it is correct, means output is exactly equal to your, we have whatever this output, given output, then what is going to be value in that case?
0.
If it is matching exactly, then the value is going to be 0. If not matching, not exactly same, then it is going to be value 1. That's the meaning here. So here, as we'll try to calculate the loss. So here is, if you see, this +1 is here, and already for F we got plus. So that means if you try to calculate the loss here for F, then for the first data it is going to be what? 1 by how many values are there? How many datas we have? And data. So here is 1, 2, 3, 4, 5, 6. 6 data we have. Now this is same as this, whatever output we got and already given, plus the same, then this is going to be 0. And for this one, this is going to be 0, 0. If you see, all are same, exactly the same. Here is -1, here is -1. So each time we are getting 0. So whatever if you calculate the loss is going to be 0. So F model is very much suitable to whatever we have the data, training data. Similarly, if we try to calculate loss for model G, now see this plus value is here, plus value is here. So loss for G is going to be 1 by 6. So this is going to be 0 for first one. Now plus is, see, here is summation is there. So that means plus. Now this is plus value, but it is -1. So that means here it is going to be 1. Similarly, we can calculate where is going to be plus or minus, and sum them all and divide. That is going to be your loss for the model G. That's the meaning here. So maybe in some question, so this model like classification, regression, and encoder and decoder. These are actually main thing. You can expect at least from these three: regression, classification, and encoder and decoder. From these three, you can expect one problem, at least one problem, and just solving. Maybe loss. Okay, already model will be given. You just need to calculate loss. Okay. Each time generally model will be given, so loss we have to generally calculate, and data will be given. Okay, you can expect from these three. So these two we have already discussed. Now we'll try to discuss this dimensity reduction. Okay.
So theory questions are also from this topic, no?
Sorry.
It is in theory questions from this topic, regression.
One theory question will be of generally which one is the regression, classification, which one is supervised learning, which is unsupervised learning. So you can even follow a pattern of the questions. You can match even with whatever you have old question paper.
Yes,
And
so there
topic
is a question in the PYQ that the loss can be 0 or not. Yes, so the loss can be 0.
So there was a problem.
Yes, sir, in the PYQ.
So question may be of that kind. Okay, so next is training data is there. Where we have some model, we'll try to see that how that model is suitable. Now so there is some set of other data which is test data. Here is what is the test data. So whatever we have already given training data, and we'll try to build a model. Now we have some set of data which will actually test how much that data is suitable. Sorry, how much that model is suitable. Like here is we are writing the learned model must not be done. So here whatever, so already using whatever the data, we'll try to build a model. Okay, we'll try to build a model. Now another some set of data would be given to test that how much it is suitable or not. That means it is different from, that's the meaning here. It question would be not be asked from here. Okay, it is just to know that okay, some already maybe some some part would be used for training, and some part you have some collection of data, and from those data some part would be used for training the data, and some part would be used for testing the training the model, and some part would be used for testing the model. And now after testing the model, you may create some set of model, f1, f2, f3, some set of model you will create, and which model is the best, which model is giving the less error, will use some data. So different from training test, will use some other data. Okay, so some part of the data which will actually try to select using which one model is giving actually less error. So that is going to validate data, validation data. This is called model selection. We'll try to use that data to select which model is we're going to use in the further process. So this is just information. No question would be asked. Okay, it is just a week one. Maybe when you will do a project, then that time all things will see what is validation, what is test data, training data. But this time it is just MLF. It is just an introduction. Try to give a gist, that what is the machine learning thing. But what is behind is that regression, classification, the lots of mathematics is there. This is one important. Yes.
First step is training
all
the model,
the
right?
data validation.
Sorry, one by one.
Aditya, please go ahead.
Yes, sir. Sir, I was asking that, sir, this training and testing and validation, all the three things are done by function or anything else?
Your voice is not clear to me. Your voice is breaking, Aditya. Your voice
Sir, am
is...
I audible now?
Yes. Yes,
Sir,
you
yes,
are.
I was asking that yes, sir, training data and testing data and validation is all
It is
calculated
breaking
from
for
loss
me,
function
or
or
I don't know,
something else?
for all of you. So whenever you are trying to speak, Aditya, it started breaking. I think there is a network issue. So I don't know, for me it's breaking or to all of you. Okay, Sudhir,
No,
yes,
it's
go ahead.
breaking for all
Okay,
of
sir,
us.
fine.
Yeah, who wants to say something? Yes.
Sir, I wanted to ask, when we are planning to make a model, there should be selection of a bunch of models.
Yes,
right?
yes.
And for all those bunch of the model, we train this model with the same training data.
Yes, yes, yes.
And after that, the validation data will be given and best should be picked from them.
Yes, yes.
Okay. But training data for all the selected bunch of models should be same. That's it.
Yeah, training. No, so it's depend on, it would be in your hand. Like it would be honest. It will like all data would be given to you. Okay. And from that data, how much part you are going to use for training, how much part you are going to test, and how much part you are going to validate.
Okay, sir. But my question is, if I have already classified this data in three parts, and first I am going to use the training data, right?
Yes, yes.
So same training data should be applied on whole bunch what I have initially
It's depend on you.
selected.
You can make the different, like you can add some data from the test data and then try to build another model. So maybe it's depend on you. It is not a bound. It's depend on you only. Because you are the making the algorithm, right? Machine learning. You are actually creating algorithm. Okay, so it's
Yeah,
depend
but
on you.
sir,
So you can use even the same training data you can use to build the other model also. Yes.
Okay, sir. Thank you.
Okay, next is this unsupervised learning is there, and in that unsupervised learning, encoder and decoder is there. So what is unsupervised learning? Unsupervised learning is, it is a kind of random. What is that? Grouping that. Like one example is there, Coca-Cola. Is there somebody is tweeted something, and you have some set of tweet like which one is good, which is bad, which is some comment or something is there. In that you want to group in that some particular tweet. So that is, that is different from, you are not going to play with, some real numbers. It is going to be a different, like here is, in their supervised learning, we'll play on the using just, if you see that output is real number. But here is not, output is not a real number. It is going to be some vector, some character, sorry, some feature. So as if you see even the encoder and decoder also, the output is final output. Like you have some data, okay? You have some data, you will compress that data, okay, and send somewhere. You will compress some data that, some maybe it will be reduced, and using the decoder, we'll again back to the same set of the same dimension. Okay, so what is that? It is not a real number, no, it is a vector. Like you have a vector, you have compressed this, and then again back to a vector. So it is not a real number, it would be a vector. But in the supervised learning, if you see that, it would always give a real number value, that is scalar value. Even, classification also, in classification either would be a +1 value or -1. In regression, you will see loss is there, that y values, but here it is going to be some feature. We are actually classifying some set of features. So here is one important encoder and decoder. Okay, what is encoder? You have some set of data, maybe it would be of in dimension d, and you may reduce that data which is in lesser dimension. Okay, so let's say here is, let's say this vector. So suppose this is one vector of, it belongs to from d dimension, mean to say you have, let's say 1 2 3, this is from R3. Okay, I had applied some function on this vector. Okay, and now anyhow, which is generally linear transformation, it will be in 2 dimension only. This vector, it would be in 2 dimension. So let's say I just can give like this. The expression is this is of input is in the 3 dimensional, but output is, we can write here, x plus z, y plus z. Now if you see the output for this particular vector is going to be what? 4 and 5. The third z value is added in the x coordinate and y coordinate. Here you can see. So now the dimension of this vector is, now it is reduced, which is in R2. Now I will use the decoder. What is decoder? Decoder is going to be another function, and it will be from that reduced from RD. In our case, it is 2 dimension, and then back to the same dimension. Yeah, it is going to be same dimension. This is your decoder. So it decode. So it previously, so this one is reduce the dimension, but decoder is expand the same in this, it will be back to the same dimension. So for example, the expression is going to be, let's say g of, now xy is equal to, let's say x, okay, x and x plus y and x minus y. Now if you see that, if you use this one, this linear transformation, generally encoder and decoder is going to be a linear transformation, because from one vector space to another vector space you are sending. Okay, now see that we have this 4 and 5. Now let's apply on here. So x value is going to be the same 4 here, and x plus y means added to the 4 and 5 would be added, which is 9 here, and x minus y, it is going to be minus 1. 4 minus 5, which is minus 1. Now previously we have in 3 dimension. After encoding that, I reduce the dimension in 2D. Okay, and then again I use the decoder here and back to the same dimension. Okay, this is the encoder and decoder. Okay,
so can you in this case have a question on this topic?
Yes. Yeah, there is one problem. I have already one problem. So let's do this problem. This one. Okay, all of you try to solve this problem. Okay, set of data is here. Okay, and encoder is, so you have to recognize which one is encoder and which one is decoder. Okay, so what is asking is that error, compute the reconstruction error. Error means law, reconstructor means decoder is what? Reconstructing, right? The same vector in the same dimension, right? So it is a reconstruction error. Generally, we call it as a reconstruction error. So all of you try to solve this and try to calculate what is losses here. All of you try this. I'm just giving 4 to 5 minutes. We'll just take a break also, and we'll try to solve this. This is this is from these 3 topics: regression, classification, encoder, decoder. I will say you that this one is the most important, even from these 3: regression, classification, and this dimensity reduction.
Sir, in the GA,
yes.
Sir, can you please zoom a little bit.
Okay, let me. Yes, sorry. I think now it would be fine.
Sir, for GA, we have
Yes,
not,
yes.
we didn't get any question from the density estimation, sir. So can we expect something in the quiz?
I will say no. Generally, for that you have to know the probability. So that's why we just try to skip. Otherwise, so we, in this linear transformation, we will study, at least from week 3 and 4 also. So that's why generally we may expect from at least this dimensity reduction and maybe regression and that classification also. But density estimation is less chance as it uses probability, and probability is generally in week 11 and 12.
Sir, we have to write the answer for all the 3 data sets, x1, x2, and x3.
Yes, because here a question is asking compute the reconstruction error, right? It is not just asking the outputs reconstructed vector, asking reconstruction error.
Sir, is it 5.333?
So yeah, just keep your answer. Yeah, probably it is, I think. Let the other. All of you, please try this. Let me know what is going to be answer. Norm is, we'll try to discuss also. Now, what is the norm? Norm is, generally if you have a vector and norm is that square the per coordinate, square per coordinate and find the sum them all and root of that. That's sum. That is the norm of a vector.
So 5.3.
Yes. So let me try it also.
So my answer is 5.33.
Yeah, the answer is actually the answer is yes, 5.33. So how we'll do this? So here is already written here, encoder function is denoted as this f, and it is like this. Decoder function is denoted like this. Already reconstruction error formula is given itself here. Okay. And now we have some data set and we have to find the reconstruction error. So how is that? We have means 3 vector, we have x1, and let's find the f of x1. F of x1 is going to be this is your x1, x2, x3. Here is the small x1, x1, x2, and x3. So this is first to sum here. Oh no, So it reduces. So this f, see that if this f is from R3 to R2, and G is our G is, see that U1 and U2 is there. That means this G is from R2 to R3. So let's calculate F1. So F1 is going to be this is 0. What is that? 1 plus 2 minus 3. Next is 1 plus 3. What is F? So here is F of x1, F of capital X2. So this is going to be, so let's calculate. This is 0 and 4. And F of capital X2 value is going to be 2 minus 2. 0 plus 2 minus 2. Next is, here is x1 plus x3. So which is, this will be added here. 0 plus 2. The value is going to be 0 and F of x3 is going to be first 2 added and next one is subtracted here. So that means 1 plus 0 minus of minus 1. And next is x1 plus x3. So these two are added here. So which is 1 minus 1. So finally we'll get here 2 and 0. Okay. This is the, we got encoded now in 2 dimension. Now apply here G and try to decode this. If apply G, here is G. If you see, this is our U1, this is our U2. So if apply decode, try to decode this, the vector will get here 0, 4, and added would be, what is that? 0 plus 4, 4. And here if you try to decode this, 0, 2, if you add, 2 will get. And here we'll try to decode this 2, 0, and U1 plus U2, which is 0, 2 plus 0, 2 we got. So here is, now again we back to in 3 dimension. Now let's calculate the loss now. Loss is exact value minus whatever encoded and decoded. This is your reconstructed vector, right? This is your reconstructed vector. First, previously it was this one. Now after encoded and decoded, we got this vector. So how much loss? So from the original minus after the reconstruction. This is the formula. That is the formula we have. Okay. So we have already. So let's calculate for each time the, first find the error vector. That is called error vector, we can say. So we have 1, 2, 3, and error for this one is, the first one is, reconstruction is 0, 4, 4. So error is going to be error vector, we can say. Error vector is going to be what? 1, minus 2, and minus 3. This is for the first one. Sorry?
Minus 1.
For the second one, original one is our what? 0, 2, 2. And reconstructed is same 0, 2, 2. So
first vector, third element is minus 1, 3.
Yes, sir. 3 minus 4 minus 1.
First loss vector,
sorry,
third element.
Why
first vector?
I don't know.
Sir, for the
am I audible clearly, right?
Sir, for the first one, the loss vector is 1, minus 2, and minus 1. You have written minus 3.
Am I audible clearly?
Sir, your voice is breaking.
Am I audible clearly to all of you?
Yes, sir.
Yeah, now it's clear.
Sir.
Because many of you have, many of your voice is clear. Sorry, your voice is breaking.
Sir, actually, in between, your voice was also breaking.
So let's calculate for third one. Original one is 1, 0, minus 1. Oh God. Audible. So I
Sir,
think my
for
voice
the
is clear,
first,
but
so for the first loss
yes.
vector, there will be -1. Sorry, 1 instead of
So
-3.
here, yeah, here it will be minus.
-1.
Yes. This
It's a
is minus.
-2.
Yeah, this is going to be -1. Now for the third one, this is going to be 202, and the error vector is going to be -1, 0, and -3. So all three we have calculated that error vector each time. Sum is there, right? This n is 3, or three training data we have. So that is 3 here. This is 3 here. Okay. Now let's calculate the norm for each. So norm of this vector now, because it is saying after calculating this error vector, find the norm and square that. So norm of this vector is going to be what? N square, just norm of square. So means here norm is going to be this, but if you do a square root of that, square of the root, it is going to be same. So let's remove that and just calculate the 1 square plus -2 square and plus 1 square. So norm is going to be generally this. Okay, square of the each coordinate, sum them all and find the root of that. That is the norm. But it's saying here square of that norm. So then let's do square. For this one, it's already 0 plus 0 plus 0. Square is going to be 0 here. Norm is going to be 0. For this one, the norm is square of that. It is going to be 6. Yes. And for this one, 1 minus 1 square plus 0 square plus -3 square, and is root of that. So it root and square will be cancel out. Just find 10. Okay, so now we have, for each vector we have calculated the error. Now just sum them all. Okay, so 6 plus 0 and divided by number of data, training data we have given, which is 3 here. This is 3. So this is 16 by 3, which is 5.33 something will come. So you can build a table, and in that you can write the answer, or like this you can apply, or you can use this process, apply of then G and then error. You can form a table. Okay, it's totally depend on you. However you want to solve, you can solve.
Sir,
Yes.
sir, why we are taking under root here? In the question, we don't have any under root. So why we are?
Yeah, under root. So here is norm is given, right? What is the norm of a vector?
It's under root, yes. But according
Norm
to the
of
formula, we just have to subtract the xi from the function, right? And taking square.
yeah. According to the formula, it's just doing the square of each coordinate.
Then if I solve by using the formula, not taking the norm, would it be wrong or will be right?
No, it's totally just need you have to, you have to enter the correct answer. Nobody is going to ask which method you are going to follow. Inside in your calculation, you don't need to write like this. I just writing square root and all to explain you what is the norm, and then root of square of that. Okay, I'm here just writing to know you that this is the norm and square of that.
Sir, I'm
Okay?
asking something else. If,
Sorry.
if we don't take the under root and if we will take the square, then the answer will be different, right?
Yes, answer is going to be different. Yes.
Then the answer will be wrong if I don't take the norm. I don't
So here
understand
is directly mean to say 1 square minus 2 square plus 1 square, and what is going to be that? Here is directly mean to say minus 1 square plus 0 square plus minus 3 square. That's the meaning here.
Oh, okay. Thank you.
Okay. So here, what is the meaning of each time? Norm of square is going to be just square. If suppose you are getting the vector A, B, C, after getting your calculated till here, you got the vector this one. So this whole value is going to be for vector is going to be just square.
Got it, sir. Thank you.
Sir?
Yes.
Sir, I have a doubt with the notations over here. So x subscript 1, won't it generally denote the first coordinate of x vector?
Yes. So generally, it is kind of either it could be written here. If it is writing like this here, that means here it's telling you this first coordinate. Maybe set, training data set is maybe writing like this also. This tells you the data sometime, but so yeah, data, and here if it is one written, that means it tells you the first coordinate. So it's depend on you if you're writing. So it would be means here it's clear, right? Here is I'm just writing that's why small x1, x2, x3. This is the capital
Sir,
X1.
in this question, they have already given the formula, sir. Do we have to remember the formula, or will it be given?
So it would be good for you to remember that formulas each time for each regression classification. Try to remember the error in this problem. Yeah, formula is given. Okay, but
And
I will
here only 3 data set is given. So this time also almost like 3 only they will give, no? Not big table.
Yeah, generally yes, generally, because if we give more data, then it would be going to be longer, and here is just test your knowledge, not the calculation.
Okay. Sir?
Yes.
Sir, if instead we have small x subscript 1, so in that case it will be the first coordinate of the vector x, right?
Small, yeah, subscript, yeah, generally that is represent the coordinate. Yes. Generally it represents the coordinate, first coordinate, second coordinate, third coordinate. Capital X1 is generally represent the data. Okay, now next is density estimation. So many times already in starting we have I have told you the density estimation. Generally we'll see here just a formula to it is, this is just a revision, so can quickly I will just tell you the formula only. Here, let me make it smaller. So what is that formula is, you have some training data. Okay, it may be of some particular, that is tells you how many coordinates are there, that is RD, in which vector space is belong, or no, how many from like XD, how many points are there, coordinates are there, it's representing superscript here. Okay. Each data belongs to RD. Okay. Now probability mapping. So surely, so if suppose, but very less chance I will say to come, but again this is density estimation. It is a kind of probabilistic model. So probability would be given for each data. What is going to be probability? So see that this is a real value. As you know, the probability is always lie between 0 to 1 only. So that is going to be, and sum is going to be 1. So that is the probability model is generally, that is here is probability model is P. Okay. Goal is, what is the goal is generally what is here. If you see what is the meaning of goal is here, we'll try to get the reconstructed vector. So what is here? We'll try to get the large. Px is large. Generally, that meaning is large if x, the data belongs to, training data, and the low meaning is that if the data you are giving that is not from the, so it is not important. Generally here is loss. It is not much important. Here is the what is, you have some model is given and calculate the loss. That's the meaning here. What is going to be the loss here? So loss is just finding the log value of the each time, whatever the probability you are getting for each. No, see, if you are as here encoder and decoder, you are getting, or in regression itself, you have some model is given, you are getting some real value. That's the regression. Okay, so whatever real value you got, same case is here. Now probability, in probability you are getting some real value here, all plus positive real value. Okay, whatever you we the value in the log of that, minus log of that. Okay, so for each data x1, x2, x3, how many data is given, for each data try to calculate the log value of that, okay, minus of each time, and sum them all, and now divide by the number of data. That would calculate the loss. So example is very neatly in lecture sir is explained. Okay, how we'll calculate. So surely here this one will be given p probability. It would be of, generally probability is, if it is belongs to the training data, that it would be on, from that interval. If it is some interval, then probability of getting that is going to be 1/5 or some whatever the value. If not from that interval, otherwise generally, then value is going to be 0. Some probability would be given. Okay, so for each time we'll just calculate the probability. For each data we'll try to calculate the probability. Okay, and now we'll take the log value, generally log of minus log of 1/5 each time. Will, if it is 0, then log 0, or maybe some value would be here, or maybe what is that, log value is given, then maybe not 0, something will be here. Okay, so each time minus log of that, minus log of that, minus log of that, and sum them all and divide by the number of data it is given. It is going to, okay. This is the density estimation. Okay. This is all about in week 1 only.
But density estimation we won't be getting now.
Yeah, very less chance to be there. Very
Okay.
Anyway, I will say you can skip this for the at least for future.
Okay, thanks.
Okay.
Sir, I did not see any questions in the PYQ also.
Yes. So Ian, that's why I'm saying if you follow the pattern itself of which one, that would be enough. If you just cover those topics also, I will say you 80% marks will get that. So here is just need to practice yourself for the problems. That's why in starting itself I said, yes. That's why in starting itself I said that if you know the concept, that would be easier for you to get the more than 60-70% mark. You just know the concept. Yes.
I'm unable to get from where I can access the PYQ, sir.
PYQ is I don't know. T is generally discussing also. What is
I got one paper, but
generally T is
There's a website. There's
yes.
a website for PYQ. We will share the link just a minute.
Yeah, maybe you can here share the link chat. That's so that others can get.
Name is Ace Grade, I guess. Yeah.
Okay. So let's move on to the week 2. So week 2 content is, generally whole some maths 1 and maths 2. Generally the calculus thing is there, set functions, and then continuity, differentiability. Okay, and then move on to multivariable calculus is there. So differentiability and continuity in the multivariable. There is approximation is there also, linear approximation, quadratic approximation. Okay, there is a finding the tangent. So these are all in the week 2. So I just write the I just quickly tell you what is that in week 2, and maybe definitions or formulas I will just write. So like set is all of what is the many times data set, collection of data. Set is a well-defined object. Generally, the definition is that it is just well-defined collection of objects where you will just write the number of objects just can separate by a comma. That's the meaning of the set. Okay, but more important is that after knowing the set operations are there. Based on that, we'll move ahead to function. So function is defined on set only. What is function? Function is from a set to another set, from a set to another set. So if you know this function, so generally we started from 6, 7. We know the function, maybe 7, 8. I think 7, 8 is standard. It's a sequence only. This here sequence, and from here we'll started the calculus, entering the calculus. Sequence is also a kind of function. Okay, where the domain is a fixed thing and range could be any real number. Sequence is always, if you're in a childhood, sorry, not in 12th level, generally we know it is a kind of it will follow. There is a starting term, common term is there, but in more general, sequence is a kind of function where we'll give the input could be a counting number, output could be anything. For example, this is this one, or maybe sin n itself. Best one is the sin n. This is a sequence, okay, where the n represent your counting numbers. You will input starting from 1, 2, 3, 4, 5, okay? And this is going to be the terms. So this is first term, sin 1, sin 2, second term, sin 3, third term. So these are the terms you have. So main thing is that sequence is either it will give a limit or it will not give a limit. So like sin 1 by n sequence. So here is this is 1 by n, sin 1 by 1. So sin 1 will get this is 1 by 2, 1 by 2. So this sin 1. So sin 1 by n, this sequence, you have a sequence, a limit is going to be a fixed real number where the output is actually fall around that. What is the limit? Limit is actually for a sequence is that the outputs you will get when you substitute very large number in the that sequence, in the sequence, the terms or output you will get, it will be around some fixed number. Like if you give here very large number, n is 999, okay, the output would be what? Around 0 only, because to 0, 1 by n, and sin 0 will converge to 0 only. So whole sequence will converge to 0 value. So whatever you will substitute here in place of n, very large number, this value is going to be around 0 only. That's the meaning. Is there any fixed number around that your output is coming? That is called the limit of a sequence. So for a sequence, limit is you are able to get, that is called convergent sequence. If not, then divergent sequence or oscillating sequence. Then after knowing the sequence, move on to the limit of function. From here, the calculus, limit itself sequences started, but yeah, this limit is there, limit of function. What is limit of a function is that the same limit as it says. Suppose your x approaching to 5, that means here you are giving the input in a function around 5. Here approaching to 5 means you are giving the input around the 5, and output, it tells you if limit exists, that means output you are getting some fix in output, around that your output is coming. Your input is around 5 you are giving, so output is also you are getting some fixed number or not exist, or maybe infinite. So if we are able to get that fixed number around that your output is also coming, then we'll say limit of the function is L. So there are two ways, left limit and right limit is there. Okay. I will actually try to solve some problem on based on that. Let me finish this limit thing is there. Then continuity is that whenever why we are studying this all, because maybe you have some function, okay, so we are unable to get exact break, okay, because your function is defined like this, so that you are not able to classify or not able to recognize that error gap or something, okay, but using this calculus thing we are actually see that where is the gap and what is the actually can we feel that gap, or anyhow can we deal with that gap, or maybe that error, whatever error in get that function we are getting, can we deal with that. That's the use of calculus, okay. So here is continuity means whatever the limit value you are getting, that L, and whatever already in the function value it is given at that point, is both are same or different. Sometimes that's the error is there, maybe function value is different from the limit value, that's the error maybe there. So if these two thing is happening, if function value is different from limit value, then function is not continuous. If both are same, then it is going to be continuous. So what is that? Limit value is equal to function value, then we'll say it is continuous. And differentiability is, we can know, you can use in the terms of tangent. You can know in the terms of tangent. Differentiability is that, what is the differentiability is that if you have suppose a function and at particular point you are able to draw a tangent here, at that point directly say function is differentiable there. What is the differentiability is that we'll use that differentiability definition to find the derivative of a function. Slope, what is that? The slope of, right? We in a line there is a slope, there is a characteristic of a line which is that slope of a line. Similarly, we'll try to calculate. So this is for a line. Suppose there is a graph, this simple function. So for a particular point, can we able to calculate the slope? That is your derivative. If you are able to calculate the slope, then we will say function is differentiable. If we are not able to calculate the slope at a particular point, then we will say function is not differentiable. So there are many terms. So derivative is actually used to calculate the slope of a function, as we use in the line. And what is the definition, and or what is how we'll calculate? So directly the basic rule is generally says find the limit. Okay, the definition is that h goes to 0. Okay, function differences around that whatever the output you will get, and exact at there. So let's say here it's not h, a. At particular point we will actually find the derivative is that the limit is the limit that some around function value and exact value at there, and find the limit of that. If this limit exists, so this is exactly the derivative value at a, means slope at point a. This is the here. And generally many functions are there, like suppose you have xn, x to the power n, the derivative of it is going to be n, x to the power n minus 1. Some standard function e power x, derivative of e power x is just e power x. Log is there, so derivative of, if it is the base is e, then 1 by x is there. Sine is there, the derivative of it is going to be cos x. Cos is there, then derivative of it is sine x. Means in function itself, you have derivate that, you will get a function. Means what is the derivative at particular point at a or 2, or let's say any point, we'll just substitute here in the here, n time a to the power n minus 1. So this is the beauty of some specific type of function. We can directly have some formula to find the derivative of this. So this is in one variable case. Similarly, it is same as the in multivariable also. Okay.
Sir, for cos x, it will be minus sin x.
Sorry, yes, cos is going to be minus sin x. Here is minus sin x. So let's solve this problem. Okay, I will be good to go with a kind of this problem. It will be more discuss concept here. So we have this function fx, which is in the mod x into x minus 2. So here is what is the limit. This x approaches to 2 positive, x approaches to 2 negative. This is called right limit. This is called left limit. I just said right. You can approach to 5 from left and right. So from left you are approaching, that is called left limit. From right you are approaching to 5, that is called right limit. So is this left and right limit are same? That's the question in the first option.
Yes.
Okay. In the second, so all of you try to solve this. Which option is going to be correct here? Please let me know. Yes. So let's do quickly here. So here is we have function mod of x minus x into x minus 2. So if you write this function, what it means that if your x is, so it is for all real number, right? Mod is defined for all real number. This means that when x is less than 0, in that case, what is going to be? This is minus of x minus 2. Correct? No.
Yes.
So will the limits not change because of the function inside? Like will it directly be less than 0, greater than 0, or?
No, I'm actually writing just a function, not changing I'm doing nothing. I'm just writing the function expression itself. What is the meaning?
Alright, sir. No, sir, because like it'll be if x into x minus 2 is less than 0, then it's minus of it, right?
Yeah. So yeah, that is what I am checking actually. When x is less than 0, then your value is, this one is negative and this one is
Yes, sir. Yes, sir. That is also negative only. So
so
it will
then
be
it will be become positive. So
Yes,
yes, now it is fine. So what is the meaning of mod is actually anyhow we'll try to get the positive one, right? That's the meaning here, mod. Means if here substitute here is keep minus, that means it will become this part is become positive. That's the meaning of mod. And when x is in between these two, then I want to make our output value is positive. So how we'll keep it good? It is going to be minus of this or just of same. So we can check here. So this is less than or maybe greater or equal to. So however, how the function is defined will do either it could be, we can write like this, or let's do it here. So let's find the left limit directly here. That is right limit here. So right limit is going to be limit x goes to 2 plus mod of x minus 2. Okay. So this is the function we have. That means your two values, this one is positive, means so not greater than 2. If it is greater than 2, so this is the positive one. And this is already positive. What it means that it is just substituting here 2, right? Because there is no in denominator, so that we should to cancel or do something. Here just need to substitute because this part is already positive because we are approaching to 2 from greater than 2.
Yes,
Correct?
on the right
That's
side.
here 2 positive, 2 to the power positive. So yeah, that means just need to substitute in that. So if you substitute here, we'll get 2 into what is that? 2 minus 2,
So
which is 0. And let's do the left limit, which is going to be limit x approaching to 2 negative mod of x minus 2. Now here we have to see. So let me. So now this value here, this means that the x value is lesser than 2. Means this part is going to be negative.
Yes, sir.
And this is already positive because we are around that, around 2. So this part is positive, but this part is negative. And now negative and positive become negative. So that means here we have to keep here, or maybe here what is that? We have to substitute minus
Yes.
2 minus 2. That's the meaning. So, but still 2 minus 2 is there, that it
0.
So left and right limit is going to be same. We have to check. Is function is differentiable at 0 or no? So directly let's do as the definition is there, h goes to 0, f of 0 plus h, function value at 0 divided by h. So here this limit is there, then we have to, because mod is there, then we have to be careful with, positive sign and negative sign. So here is finally h goes to 0. So f of h minus f of 0 upon h. So this is limit h goes to 0. So h mod of h minus 2. And function value at 0 is just substituting 0 already would be 0. Function value is going to be 0. So we can remove that. And this is upon h. Now we have to be careful. 0 approaching to 0 is not. It contains both positive sign and negative side both. We have to deal with separately. Because this limit is for both positive and negative both. This is general limit. There is no left and right limit. Okay. In whatever in derivative case, I just wrote this limit. So left and right we have to deal with separately. So if it is here means if you do for the left one, so limit h goes to 0 means here 0 negative. In the case of 0 negative, what is going to be this? If you 0 negative,
h minus 2.
So this is we want this is negative, this is going to be negative means positive.
Yes,
Become positive is there,
So
just
zero
writing
minus 2.
h minus 2. And
Yes.
now just need to substitute here 0, we'll get 0. Oh, so sorry, upon h is there, no? Upon
Yes.
h is there.
So you get minus 2.
Going to be. So what we'll get here? Here is this one is negative one, right? This is negative. This one is positive we'll get, but here this one is the negative h is there. So what is going to be value now?
Minus 2.
So this is going to be negative. This one is a negative of 0 minus 2. This will get.
Sir, why negative of
why negative is there? This h is your negative.
But sir, both numerator and denominator h is negative, so
Sir,
negative
it's in
negative will
the
cancel.
No. So here what is that? You are getting the mod value here, right? This
Yes.
is mod value. That means this one is numerator is positive.
Yeah.
Numerator you got mod value, right? So this is going to be positive. That's
Yeah,
fine.
but
But
numerator is positive, but
no
because
negative. At denominator there is no mod. It is in denominator your h is negative, right?
sir,
Yes,
but numerator is positive because the single h is negative and the h minus 2 is also negative. That's why we can say that numerator is positive. So the single h is itself is negative in both denominator and numerator.
Sorry.
Yes, sir. So basically, like all the h's are negative. Like in the numerator, also the h into h
Okay.
minus two. So you don't need a
Yes.
minus
All
symbol.
h is negative. Yeah. Sorry. Here is what is the meaning? All h is negative. Yeah, that's the good. Yeah, I just missed that. So here is all h is negative. This one, all h is negative. Okay. Yeah. Oh yeah. I just missed that.
Yes.
Yes. So all h is negative here. Here this one, this h is negative also. Yeah. Sorry. This h is also negative. So all negative here. That means minus 2 will get. Yes. In the case of right limit h goes to 0. What is this here? So h, this is from positive 1. So
yes.
what is going to be now here? Okay.
Minus h into h minus 2.
Minus h here. Because this part will give negative. This we have to manage. So minus h is there. That's why. So here is all h is now positive. Correct?
Yes.
And by this way, this will give here cancel and cancel is this is going to be plus 2.
Yeah.
So we are getting two different limit. When we are evaluating this final limit, left and right limit are different. So this is not differentiable at 0. Yes. This is not differentiable at 0. At 3, it will behave positive, right? Because if you do here is this is at 3 around, it is just we have like a simple polynomial. This one. That's the meaning here. Because there is no issue with 3. It is issue with 0 and 2 only. At 0, there is a problem, and at 2, there is at 3, there is no problem. It is just we have like a simple polynomial. So, mean to say, just derivate this one and substitute 3. And continuity is at 0. So, mod is generally, we know, continuous. Mod is generally at, the problem is only at derivative, but mod function is continuous at 0. So, at any place, if it is added to with the x minus 2, x minus 3, or x minus n, anything is there, there is no effect with mod in the case of continuity. So by this way, we can say function is continuous there. So, okay, so what is going to derivate value 3? It is going to be 4, or
yes,
what is that?
This is going to be 4.
X square minus 2x. So derivative of this is going to be 2 minus 2x minus 2. So at 3 is going to be 6 minus 2, which is 4. So this option is going to be true. So first one, third one, and fourth one. So these three options is going to be.
Sir,
yes.
Graphically, this is not going to be differentiable at x is equal x equal to because it is taking the subspace.
Yes, directly, you know what is the graph is going to be here. It is exactly the same. This, okay, and this here too, and then subspace and this. This is the graph of mod of x minus 2.
So because of that critical point,
so these two are point are actually sub corner, and at these two function is not differentiable. Rest all it we have like a polynomial, simple function. Okay. So by this way we can choose the options.
It says about 0 also, sir. At 0 also.
Yeah, at 0 only. Here is the problem critical and 2 at critical. So this is 0. This is 2.
Okay.
Okay, so this is one. Okay, now there is one problem in the multivariable also. This one. So I think this, yeah, this is the. So in the multivariable, so let's discuss a bit about now. Almost we have discussed about the continuity differentiability in one variable. So in multivariable, in multivariable, we are not going to discuss much about the differentiability of the multivariable. We just discuss about the partial derivative, gradient. Okay, these all we're going to discuss only. Differentiability is not much important, and it will be, when we'll do pure maths, then it will you have to learn. Otherwise, there is no much need. So what is the partial derivative is? Suppose you have a, so generally here is, we'll go to, scalar function. What is the scalar function? So you have two variable, then output is going to be real. Simply one example is there, x square minus y square upon x minus 1. This kind of function. Means if you see here, substitute x and y value, you'll get a real value, scalar value. So that is called a scalar valued function also. Okay. So in this case, what is the partial derivative? So simply, I will just, let me take a simple example. Let's say this is x square plus 3xy plus y cube. Suppose this is the function we have. Okay. Now partial derivative is assuming to be y as a constant and derivative it. That means here this is going to be with respect to x. It means that we have to just derivate this with respect to x and assume y as a constant. So this is 2x, and we will assume this is constant here. There is, so that means this is going to be, there is x is only. So this is 3y, and this is 3y square. Sorry, 3y, and this is a constant. So this is going to be 0. So 2x plus 3y. Similarly, if you do the partial derivative with respect to y, so this is going to be this is going to be x, we will treat as a constant, and y as a variable. So this is going to be 0 plus this is with respect to y, it is going to be 3x, and this is 3y square. So with respect, so we, once we know the partial derivative like this, so there is a concept gradient. Gradient of a function. Gradient of a function is just writing, gradient is, a vector valued function. Vector valued means here writing like this. Gradient you will get the writing the partial derivative like this in the vector form. So gradient at particular point, let's say at 1, 2 is going to be partial derivative value at 1, 2 for x, partial derivative value with respect to y at 1. This is the gradient at 1. And there is one thing is that steepest ascent and descent. What is that concept? Steepest ascent and descent is that in which direction, if we move, will be the function, that function value will be the, will get the maximum. That's the meaning, I think, steepest ascent and descent. And in the case of steepest ascent, and in the case of descent mean, it means that where, in which direction we'll move so that the function output is going to be minimum. So, and the direction is easily we can get using the gradient. What is the steepest ascent? Somebody is asked. Suppose at you have a point A, this 1, 2, okay, and here is our function, okay, our function. So at, suppose here function is passing through from that point, in which direction I will move so that we will get the so steep ascent. In which direction? What is going to be that direction? Direction is, I said this is, you will get a vector here. This vector is actually, what is vector? Contain the what? Magnitude and direction also. So in which direction I try to move means in which, what is the going to be the vector? so that in that direction I will, or in that direction, in that vector we will try to move, we'll get the steep ascent. So that ascent is going to be the gradient of the function at that point, just at that point, positive value of the gradient. And a steep descent is the direction negative of that gradient of that point. That's the here steep ascent, and this is steep, yeah, ascent, and this is descent. Okay, so this is the multivariable thing, and there is one thing is that writing linear approximation in 2 variable and 3 variable. Here again the gradient will work, help us to find the linear approximation. What is the linear approximation? Linear approximation is actually, suppose we don't know the function, or what is the linear approximation is mean, suppose in the one variable case. Okay, what is the one variable? Suppose we have a function this, okay, and we know function till here only, okay, and there is a gap, and after onward we know again the function. In this gap we don't know, okay. So what is going to be the approximated value in this gap? We don't know what is going to be function. Maybe function only at here, like this exact function, we don't know what is that. Can we get an approximated value? So there are different type of approximation: linear approximation, quadratic approximation. So what is the meaning is that maybe at here we'll just think function is we have like linearly, maybe function we have like a quadratic, maybe at in this gap function we have like a polynomial of 3 degree, 4 degree, 5 degree. So that is called linear approximation. This, if you are approximating in this gap by a linear function, that is called linear approximation. If you are approximating this in this gap by a quadratic function, then it is called quadratic approximation. We think as a, with a polynomial maybe higher degree, then we'll say polynomial maybe 3, 4. It's depend on how many degree you are using to approximate the function. So how we'll get this all? Yes.
Just one different question, sir. How is
Yes.
there any relation between directional derivative and slope?
Yeah, I missed that, directional derivative also. Yes.
Is there
Yes.
any relation between slope and directional derivatives?
Yeah, so yeah, I will back to this linear approximation, this all, but this is the meaning of, okay. And yeah, let's back to this slope, right? You said the slope and directional derivative.
Yes. Is there any relation between that directional derivative and slope?
So actually, what is the slope of a function? We said, right? Slope is, what is the slope is generally, we'll think about a line, right? And I said, right, if you have a function and at particular point, we'll try to find the slope of the function. But when you are in multivariable, okay, in that case, because so in that case your function is not in like this, it would be of maybe like this, so it's needed 2 variable, actually 2 out inputs. It's needed 2 input. This is going to be input, this is going to be input, and this is think at as a height. This is your z, this is at the height, okay. So we needed 2 things. So here it is not only one direction, here is many directions, right? So here is, in this case here, in different words, slope is actually giving a direction, this direction, I mean that in which this is in a tangent kind of direction. So in the single variable only 2 direction is there, like this or this. But in multivariable case are many direction, I said, right? There are many direction. So in multivariable case we need a directional derivative, but here is only the derivative. In one variable case only the derivative thing is there, but in multivariable, we need many direction are there, right? Here is only two direction. Or here is in the tangent, what it is saying to be just a line. Of course, with respect to this line. But here, if you think this is, if you think this is vector, so connecting to that vector, this is one line, this is one line, this is one line, many lines are there. So mean to say,
that is why one vector is given to find the slope in delta.
Yes, that is why. In which direction you are actually finding the direction derivative, that slope of, in which direction you are finding the slope of that particular, in multivariable case, direction.
There are saddle points also in this syllabus.
So saddle point is, I don't think here is the maxima or critical point is there in this week 2. No, I don't think. Only the directional derivative is there. Okay,
no,
so
sir, it was the maxima, minima, and saddle point. It was in the week 2.
In week 2.
Yeah.
Okay. Okay. We'll discuss also. Okay. So here is that, okay. I think so. Yes. I think this problem is on the maxima minima also. Whatever I have there. Check once. Yeah, this is the directional. Okay. Okay, we'll discuss about the maxima minima also. So let's discuss the directional derivative. So what is the directional derivative is, so now see that this is the function we have. So we needed at a particular point, okay, so here in directional derivative, we needed two things. You are at point here, and in which direction you are asking the directional derivative, means slope, in which direction you are asking the slope now. Here in the real case, only one variable case, we have only two direction. Mean to say, finding the line, there is, mean to say, only one direction. Two direction mean to say either only this side, means like this only, this side or this side, means only saying to be just one side. But here is many directions are here. So in which direction you are asking the slope? That's the question now. So that's why in directional derivative, you will see a point and a direction, means again, it will be a vector. So here it will be a vector, means here that is called point generally, and in which direction. So for example is that, let's say you have a function fx y is equal to x square plus y square. So somebody is asked, find the directional derivative, okay, at point 1, 2 in direction 1, 1. So whenever somebody is asked direction, no, so direction is, we think as unit vector. So this is not a unit vector. We have to change in the unit vector. So that means here it means, we have, if we change this in the unit vector, means just divide by the norm of the vector. What is the norm of the vector is coordinate wise square and then sum. That is the norm here. That means here 1 upon root 2, 1 upon root. Now this is this one. This one is the unit vector of this vector. This is the unit vector for this vector. Now what is the directional derivative at point 1, 2 is that, find the gradient of that function, which is f of x, partial derivative. So this is going to be partial derivative is 2x and 2y. Okay. Now find the what is the gradient at that point, means at 1, 2, where it is asking at where, find the gradient at that point. So which is going to be a what? This is 2 times 1, 2 times 2, which is 2, 4. We got the gradient now. Now directional derivative, okay, directional derivative is time at that point, sorry, gradient at that point, dot product with in which direction the directional derivative asked. That means dot product. So directional derivative is, so actually derivative is going to be always a scalar value, okay? Derivative is always going to be scalar value. So that's why here is a dot product. So this is going to be 2, 4. We got the gradient already 2, 4, and dot with the direction. So this is going to be dot is 2 upon root 2 plus 4 upon dot product means coordinate wise, just do the multiplication. 2 into 1 upon root 2, 4 into 1 upon root 2, and something. And finally, whatever the value will get, that is your directional level. Okay. Is it clear to all of you?
Yes, sir.
So this, based on this, we have one problem.
So I had one question. For
Yes.
that specific number, how did we find the gradient? Matlab, what was the f? What did we take for the gradient?
What did we take for the gradient means? Sorry, I didn't get your question.
What was the second last step that we did before finding the directional derivative?
Before finding the directional derivative, I just found gradient. So gradient is fine, I think, right? This is fine. Actually, what I did, somebody's, sometime maybe in the problem, direction given in unit vector. It is always should be. So whenever you are actually finding direction derivative, you should to change your vector in the unit vector, and then do the dot product. That is the definition of directional derivative in that direction. So find the gradient there at that point at 1, 2, where the asking, which is we got this one, and direction we have, and do the dot product, gradient with the dot product with the gradient and the direction, which is this, and something. Now you people will be find this one easier, but see, try to all of you this. What is going to be the find the directional derivative of f at point 0, 0 in the direction, okay, of the vector 1, 1. All of you please try this. Let me know what is going to, which option is going to be correct. Directional derivative is asked here. All of you are trying this?
Yes, sir.
What is the answer?
Option.
Correct option? Sorry, what is the correct option?
A, sir. Option A.
Option A. Someone others getting the same option or getting different option?
Yes, sir. Option A.
So actually here two concepts is used. Maybe many of you may got just use 5, but here is two concept is used here. Can anybody tell what is the first concept? Then we'll move on to the directional derivative. What is the first concept here used? What is the use of continuity of this multivariable thing? Because this limit is given. What is the use of this limit?
That it will be differentiable at 0, 0.
But there is no word is used here, right? The differentiability. Continuity word is used.
Yeah.
So, okay, so let me explain you. The limit is actually given because, see, function value is not given at 0. So it is asking the directional derivative at point 0, 0. Okay. I mean, at point we have already given. Direction is, yeah, clear, 1, 1. What is the function value at there?
5 will be the value at f11.
Oh, okay. In the directional derivative, do we need the function value?
Sir, why we need that function value limit? Why we need to use that concept over there?
Yeah, actually, there is no use of it, right? Okay, I thought maybe it will be
Because
useful.
derivative is given and point is given, so can we directly put that point?
Yeah, actually, there is no use of this. There is no use of that. I think it is. Oh, yeah, there is no use of this because we have the partial derivative given this one. Okay, so that means gradient of the function is going to be at 0, 0. At 0, 0 is going to be
1, 1.
1, 1. And yeah, vector we have to change in the unit thing, which is of just dividing by the root 2.
Root 2 open.
And now we have to take the dot product. So if you do the dot product, this is root 2 times 1 plus 1. This is 2 upon root 2, which is root 2. So there is no use of this 5. Yeah. Yes. Okay. So this is one thing. Now there is a critical point. So critical points, you know why the name is critical point. So in one variable case we'll see, and then maybe slightly move on the multivariable also. But method is same, going to be same. Okay. So what is the critical point? Critical point is
Excuse me,
those
sir.
point. Yes.
Before this, can you explain once what is? I mean, can you explain the Cauchy-Schwarz inequality?
Okay, Cauchy-Schwarz linear Cauchy-Schwarz inequality, right?
Yeah.
So Cauchy-Schwarz is generally it is called, you know, so see it is look like difficult, but in simple word, what is the meaning of the Cauchy-Schwarz is that you have, what is that, two vector, and okay, let's say you have vector v1 and v2. Okay, just a second. It is okay. So suppose you have two vector v1 and v2. Okay. So if you have two vector and suppose I am taking the dot product of these two. Okay. So generally it is denoted like this also. Sometimes it is like this. Maybe here is comma, just comma. Maybe dot product is like this also. Maybe V1 transpose V2 also, like this also.
Yes,
Many representations are there. Okay, because vector is generally denoted like this in a column wise. Okay, so that's why the dot product is saying to be transpose of this is going to be like this, and vector is like this, and if you multiply these two vectors you will get a scalar. Okay,
yes,
that's the meaning here, dot products. So whatever you have now, dot product, and if you find this, see, dot product is going to be scalar value. So absolute value of this dot product, okay, absolute value of this dot product, all are actually same, is going to be less than, okay, going to be less than norm, which is called the length of the, okay, of the separate. If you do the separately find the norm of each vector, to separately find the norm of each vector, the dot product is going to be less than these two. Okay, so simply what is the meaning, in the scalar case, is in scalar case, what is that? Norm of, sorry, mod of a plus b is what? Less than or equal to mod of a plus mod of b, right? If you know
yes.
in real, this is exactly in the, if you do in this, in the vector case, this is the meaning of that this
Okay,
is also kind of triangle inequality or Cauchy-Schwarz equality. What is the meaning in mod value? Three, this mod of a plus b less than mod of a plus mod of b. That's the meaning here. We are taking dot product. It is separately just do the dot multiplication. So what is the dot product? Is the sum of the separately coordinates. Multiply the each coordinate twice. Do the multiplication. Add them all. That is going to be lesser than if you do the multiplication of the each norm. Sorry, norm means length of the vector. This is more. So Cauchy-Schwarz inequality is most generalized form of this, you can say. This is in the
okay,
real,
sir.
but this is of in the vector.
Okay, sir. Sir, but what is its use?
What is the use of this is, when I think you will be in week, it will be three, no, fifth or in 5 on 6, when you will try to, do not even this, no, not 3 and 3, even you will do the optimization. Optimization is generally, optimization is what? We'll try to find the maximum value of some vector or maybe some set of vector, which one give the maximum output, maybe whatever when you will study, you will see
Yeah, yeah.
there optimization. So there will need the inequality.
Okay,
Okay,
got it, sir.
this is the inequality we have. So in not 3, 4, in optimization will start from I think 7. Okay, 7, 8, and 9. I think yes. So there
Okay,
you will see the use of Cauchy-Schwarz.
okay, got it, sir.
Now, critical points I was started to discussing. So what is the critical point is that, where the critical point in graphically it will easier to understand. Suppose you have a graph of function and suppose there is a break here. Okay? This is a break, and maybe at particular point there is a sharp corner. So this sharp corner or break points, okay, maybe at particular point your derivative is not exist. Sometimes derivatives not exist means, your tangent or slope is going to be infinity, because that's the meaning here, not exist also. So there are three actually cases. Maybe for a function there could be a sharp corner in the graph of the function. Maybe in the there is a break, means here limit is not exist, means limit and function value is not the same. Okay, maybe there is a kind of this break is there. Maybe till here is this and there is a break like this. So there could be a break. So at these points, okay, at these points, see that what is happening. Sharp corner, their value change. At here, see that the value change is there. At here, the saddle point means it's look like something is from maxima to minima is happening, function value is happening, but it is not. This is called saddle point, where the derivative is not exist. and others see the critical point. There is a function value differences, right? From minima, there is a jump is there, sudden change is there. At here, see, sudden change is there. And another thing is that maybe sometimes, like this. So at here, local maxima, maybe here local minima. So see that at this point also called the critical point, because at this point there is a value change is happening. So that's why the word is actually also came critical, means value changes are there. At this point, some value change, something is happening with the function and with respect to value of the function. So maybe local means value changes there, from lower value to sudden increase is there, maybe from increase to sudden decrease is there, maybe what is that, sharp corner is there. So at here is also sudden in from decreasing to increase is started. At here there is a jump in the in the value of the function. And maybe at here even it's look like a in the graph, it's look like in the graphics actually, it's look like there is a maxima to minima is there, but there is no, there is a twist only. These points are actually called saddle point. This is in the real one variable case. And how to get this critical point is that just derivate that function, okay, and equate it to 0. You will get an equation, and just find those function input values of that x values. Those values is going to be generally called critical points. This is one point. And another is sometime we may get at a particular point your function is not differentiable, right? At here like this one, or maybe this one, these 2 points, these 2 points are also critical point. So maybe the two cases are there. If you derivate that and equate to 0, will get critical points, and you will include those points where the function is not differentiable also. That is also a critical point. So same, it is going to be same behavior with, okay, so once you find the critical point, okay, twicely differentiate that function, okay, and if this is at that point, okay, at a, your this value, the double derivative is going to be 0. That means at here your function is local, there is a local minima is there. If double derivative at a is less than 0, then local maxima is there. And if it is equal to 0, then we have to maybe then we have to further analysis we have to do, but such problem may not ask, okay. But okay, if less than 0, then local maxima, if greater than 0, then local minima is there, okay. In multivariable case, finding the critical point is the same. What is that? We have to find a partial derivative with respect to x and equate to 0. We have to find the partial derivative with respect to y, equate to 0. Okay. Maybe more variables are there. So similarly, we have to find each of them and then equate it to 0. We'll get some equations. And using these equations, we'll try to find the x value, y values. And we'll form a point, right? X, suppose you got x1 value, y1 value. This will form a point. Similarly, others will get a point. Now these points are actually called critical point. Okay. Once we got this in this critical point, so there is a, what is that? I think this formula is there. F double x means find the partial derivative twicely with respect to x, and similarly find the partial derivative with respect to y, and multiply them minus partial derivative with respect to x and then y. Okay, and square them, something is there. So you can check, what is the exact formula. This time I am not remember this formula. And if it is, this should be greater than 0. So more condition will come. I think this is not in this here in ML. I don't think it is ML. Is this in ML?
No, sir. For now.
No, the multivariable is not there.
Yeah, only one
Only
variable.
this tangent and this.
So yeah, remain to the linear
Critical point
tangent.
is not there.
Yeah, critical point is not there.
Yes.
So let's skip this. I think it would be there, then surely one question I had taken from the old question. Okay, so there is one now, the tangent and linear approximation. It is just a formula, tangent and linear approximation. I already told you, right, what is the linear approximation.
Yes.
already discussed that, and I will just now discuss the formula now. So linear approximation, if you're using the linear approximation, means that for one variable case is going to be what? Linear approximation of function at a at particular point is that function value at that point, derivative value at that point, and x minus a. And now if you just do the, if you do multivariable, okay, so will this derivative change by the gradient. So if it is the multivariable, okay, so here is at a means it will be a function, no, at here a. So here is at particular point a b. So it will be a function, no, in so linear function in one variable. So linear approximation is a function. So this is going to be function value at that point plus gradient of the function at that point dot product with what? X minus a y minus b. This is a vector, right? So this is the this is in the case of multivariable. This is the linear approximation. And see, the difference is that once you know the linear approximation, so what is the quadratic approximation? If somebody is asked quadratic approximation, I think it is there. This is going to be same. You have to do twicely, I think.
Yeah, after this same linear term, we have to add double derivative by 2 into x minus a.
In the case of here, we have to double derivative at there at a divided by factorial 2.
Yeah.
And f minus a square. This is the quadratic approximation. So in multivariable case, I don't think sir taught the quadratic approximation, right? No, there is no. In higher variable, I think if it is there, then what is the formula? It is just a formula. You just need to slowly keep there. I think, let me check.
Sir, quadratic approximation will come, sir. I mean,
in exam,
yes,
so
yes.
Maybe in two variable, one variable, yeah, you can expect.
Okay.
I will not give it, but yeah, you can expect some, maybe some problem. Yeah, so only in one variable case. Sorry, in the multivariable have maybe okay. So, and what's the tangent? Tangent is just in case of this one. Just here is in place of this, right? This is the and in place of this
your
one.
voice is breaking. I guess someone's mic is on.
Yes, someone mic. Let me make. Yes. Thanks, Krishnaji. So, what is the tangent? Is this is actually representing a function change with, because plane represent, sorry, line, tangent line is a represent an equation in algebraic form. Tangent line in algebraic form represent an equation. That means we need to x and y. That means y equal to this. This you can remove this quadratic. This still here. This represent your tangent line, and tangent plane is there. Z equal to that linear approximation, right side of the linear approximation. That is going to be tangent plane. This is tangent line. So there is not much difference in the approximation and tangent. In place of function, you just replace with the y, that is become the tangent plane as line, and plane similarly for the multivariable. Okay. Left side formula, sorry, right side formula is important if you remember the right side. Left side is just if you are keeping the function that become a linear function, linear approximation. If you are keeping as a y, then it will be a line. And if you are keeping z for multivariable, then it will be a plane. Okay. But right side is the same for linear approximation and the tangent. Okay. So these are the formulas we have. That's all in week 2 also. And that's all from my side also. It's much longer session. Anyone have any kind of
What will be the weightage, sir, for 1 and 2?
1 and 2 is, you can see it here. How many questions I have taken from the, see, in comparison, 2 questions from, a week 1. So we seem very similar. This kind of question you may expect. And one is from encoder, decoder, or maybe, regression or maybe classification. I will more emphasis on encoder and decoder. Please be clear with that. So these 2 questions from there and 2 questions from, this. See that this is one problem for week 2. Multivariable cases there. One is from continuity, differentiability. This one. This problem is the best linear approximation. Best approximation. Which of the following is the best approximation of this one? Use the linear approximation. See, this is already approximation is the linear approximation formula. So which I'm already discussing. Just need to. So what we think about? It is asking best linear approximation. So how we'll think it? Around 16. So what is going to be function here? Could you tell me what is function here?
A to the power 1 by 4.
X to the power 1 by
1 by 4.
This is our function. We have to linearly, so we have to find the linear approximation of this function at
around 16.
That is going to be the best linear approximation. They are a best approximation of.
It will be around 2.031 approximately.
Yeah, we just need to derivate this, which is going to be 1 by 4 of x to the power minus 3 by 4. And now derivate value at 16 is going to be 1 by 4 of 16 to the power minus 3 by 4. And then finally linear approximation is going to be
f star plus f of
function value at 16. No. So what is, so here is what? There is a difference, right? What is going to be point now? So around 16 is asking, and yeah, okay, 16.01. Okay, so that's fine. So around 16. So this is function value at there, derivate value at 16, and x minus 16. Okay, and it is asking 16.01. So what is going to be? So this is a function, right? Linear approximation is a function. So what we will substitute in this function?
16.1.
0.1 value it is asking.
No. Yeah.
0.1.
But in place of x, we have to substitute 16.1 because it is around 16 now.
Yeah. Around 16. So 16.1 minus 16. So 0.1.
Yes.
So if you, yeah, even if you want to substitute 16.1, so it will come there, or just substitute 0. Yes.
This B and C answer is very close, so we have to literally use calculator.
Yes.
No. 2 zeros are there, sir. Okay. 2.003. This is 2.03.
Oh, yeah, 2.0.
Okay.
is 2.03. Okay. Okay, so this kind of questions you can see in the page. Okay, that's all from my side. Yes.
Next session when, sir? Revision session 3 and 4.
On the it will be on Saturday 4 to 6. Yes.
Saturday. Okay.
Thank you, sir.
Sir, can you please share a PDF that you have
Thank you, sir.
written?
Whatever I wrote this one.
Yes, sir. Yes, sir.
Okay. Okay. We'll try to provide. Yes.
Yes, sir. Please upload it in the supplementary content right now.
Sure. So right now it will be difficult. I don't know. Yeah, but I will try to say to upload. I will give to the operational team right now itself.
Yes, sir.
Thank
As
you,
soon as
sir.
possible so that you can revise.
Yes. Yes. Yes, Krishna ji.
Week 4 answers actually for the MLF in the GA solutions.
Week 4 answer section. Sorry.
In the GA solutions in the PDF week 4 PDF.
It's not uploaded.
No, it's not there, sir. Please.
Okay. Okay. I just noted it and see it.
So this rank and all is covered in week 3 and week 4, is it? Rank
Yes.
and
Yes. Actually, it's around more than it is 10:30. Otherwise, I should to discuss. Somebody says the left null and null space. Let me just. So who want to ask? So, like somebody is asking in starting, what is the null left null?
Yes, sir, I did.
So very quickly, like very small, maybe I will discuss. So it's a very simple. Okay, it is very simple. Four fundamental theorem is what? Okay, four fundamental theorem is, suppose you have a matrix. Okay, suppose you have a matrix of whatever square matrix generally will take. Okay, and there are four spaces. Is that first is column space, second is row space, and one is null space, and second thing is left null space. So the last one is left null space. Okay, how we'll find the these all? So column space is, what is that process to find the column space? Change in Gauss elimination. Gauss elimination, and try to change in reduce row echelon valve, if you remember. And how many pivot you are getting there? Take those columns only. Take those columns only. Okay, and that is going to be your basis of that column space. These columns are going to be basis of column space. Or simply, what is that? Or if you are not doing this all, okay, these are the columns you have. Okay, find the span of these columns. That is your column space. Span of these column, all whatever the columns you have, 4 5 columns, find the span of this. Span of that is going to be your column space. And span of row is going to be your row space. Even this is one. Otherwise, change in the row, reduce row echelon form. Okay, and take the where you have the non-zero rows. Where is that pivot is coming? Take those rows. That is you're going to be basis of row space. Or
simply,
find
sir,
the
such a
span of
click transpose.
So that is going to be left null space. So let me tell you now what is the next. So null space is what is now the null space, just a null space. So you have this matrix. What is the process? Right side is x, y, z, whatever the how many columns are there, that many variables, equate it to 0. Okay, solve this system of linear equation. X, Y, Z values will get maybe any one of X or Y may be of some, maybe X is can be written as Y, or maybe X is written as Z, Y is written as Z. You may get this solution. That this is your column space, sorry, null space. This solution is your null space. And what is the left null space? Whatever you have matrix is given this one. First find the transpose of that. Okay. First find the transpose. First do the transpose, and then now find the null space of that. This is find the null space now. This is your left null space. This is only the theory behind it. This is all about.
Got it, sir. Thank you so much.
So what is the projection of a vector B on a subspace if it is spanned by vectors V1 and V2?
Projection is, what is projection is, why the first thing is why projection is came. The projection is came because of, if you have, suppose you have this vector, okay? Suppose you have this vector, okay? And now you have another set of, you have, suppose this is another vector, maybe set of vectors, okay? Okay. So it means, in a different word, it is generally, if we write these vectors in the matrix form, okay? And what is that? If we are, if this vector is the solution of, this system of linear equation, then it is what it means that this vector is actually nothing but in these vectors. But when the case is when this solution is not exist, that means what is the meaning of that? This vector is not lying in this, in span of this. In pictorial form, what is the meaning of this? Is that suppose these are the vectors you have, okay, 3 vectors. You got this span, okay, and you have another vector, this one, which is not lying in this vector, right? It is away from this vector. If it is in this here, then that's fine. If you do the projection, means it is lying, there is no need of projection. Projection is needed when it is out from that. And now I want to anyhow find what is going to be that, image, means, here is sun near just falling from here. What is going to be here? That shadow. That's the meaning of projection. If this vector is inside there, then there is no need to ask the projection. Projection is needed when outside of that space. Your vector you have is outside from that space. Then the projection is needed. And what is going to be that shadow? So this is the meaning of projection, I said. I don't know, is this
What's the formula for that actually?
The formula is that, so formula is here is, suppose you have a vector A and I want to project this vector on B, and then formula is find the dot product, okay? A transpose, it is in this form, dot product divide by the norm square of that whatever where you are projecting, and outside your norm, that vector B. This is the in one, if it is given only one, A is actually projected on B. A is projected on B is this one.
If B is a subspace which is spanning 2 vectors V1 and V2, how do we do?
In this case, we needed this one. Project on, suppose B1 and B2. Okay.
Yeah.
So B1 is, first find the projection on B and add with the same A transpose B2, B1 divided by the norm of B2 square, I think. So please clear with the square is there. Square is there. Yeah, that's fine. So this one. This is going to be the projection separately. Do the projection separately. That's the meaning here. If the more more vectors is there. Means 2 vectors are there. 3 vectors.
Oh, if those 2 are basis vectors, you need to add them.
Yeah,
do on each and then add them. Okay.
Yes, that's the meaning here. If you have 2 vectors are there, project them separately. That's the meaning here.
Thank you.
Okay.
Sir?
Yes.
Sir, let's say if you want to find the row space of a matrix, in that case, should we stop till REF or should you go all along the way? And
yeah, row is in the case of row space. So do that till reduce row echelon form, and whatever the rows you are getting after that is going to be the basis of row space. That is going to be the basis of row space. Yes.
So is it just for row space or column space as well?
For the column space, for column space, you have to take so here depends on, you have in both cases you have to find the reduced row echelon form. You have to do in the reduced row echelon form. And see, for row echelon form now, where your vector is coming, this pivots are coming. For row echelon form is those vector is going to be the basis of this here in row echelon form. Those is going to be the basis of row space. But in column space, suppose this column at here you are getting pivot. Okay, so it means here first column means first column is going to be the basis. You're here. This is going to be the basis in the column space. If here is the third one is your pivot. Okay, so means your third column is going to be the basis element of the column space. Suppose fifth one is coming. So here the fifth one is going to be the basis element of the column space. From here we'll take, not from here. Okay, from here, this original, from original one will take after changing here. But in the row space, from here itself, from REF, that reduced row echelon form, from here itself we can take these rows itself, and this will be the basis directly here. Is this clear?
Yes, sir.
Is this clear? From here, reduced row echelon form, once we change, from here directly we can go row space. But for the column, we have to recognize those column where you are getting the pivot and pick those column only. Okay, that is going to be the basis for column space.
Sir,
okay.
Sir, I want to clarify one thing here, that after RREF form, the pivot elements in that column, we would take the column from the original matrix in the column.
From the original one, yes. That's why I'm saying from the original for column space.
And in the row space, after RREF form, we will take that row from the original matrix or from the RREF form matrix?
From RREF, this one. You can take this one also, but this is the simplified basis. That is called simplified basis. We can take here from here this one. But this, if you take this one also, this is a simplified basis for this row space. So there is no issue with the taking this one. Issue will be for the column only from if you are taking directly from here. Okay, but for the row it will not issue. The reason is we are doing the row operations only. Because of this the issue is there. Okay, is this clear? Because why we are doing, because on RREF we are only doing row operation. Because of this, when we are taking the column, we are picking those only from the original one. But in row space we are picking here from itself. Okay, this is the differences. That why? Because we are choosing like, or we are doing like this because of we are only doing the row operation. Because of this we are doing like this. Is this clear?
So the after RREF form, the row space will be like for the first row it will be 1 0 0, and for second it's 0 1 0.
Yes. Yes, maybe here non-zero other terms is coming, non-zero entries also coming. It will be in there. Means 1 0 0 you are getting, and maybe the next row is getting 1 2. So this will be going to be in the row space.
Sir, if we want to find row space in terms of column space of A transpose, in that case, should we take it from the reduced echelon form or maybe reduced row echelon form, or from
sorry, could you repeat please?
Sir,
could you
if we are finding column space of A transpose,
okay,
so in that case also should we take it from the column, I mean matrix which is transposed, or can we take it from the RREF?
from RREF also, or it's depend on you how you are proceeding. So from RREF, just take the rows itself will work, because transpose, you know what is the transpose, just writing the rows in the column wise. So from RREF itself from original one will work. Otherwise, better is just don't mix up. If you are asking the column space of the transpose, do as the process, just do the transpose of that tab, and now process just now discuss to find the column space. That would be good. It will not mix and you will not get confused also. Go with the whatever we just discussed. That's the I will do. That's I will say.
For a matrix A, if the null space span is given, how do we find out the row space span?
Null space span is given. So no, so no, it will not give. It will give only the rank thing. I don't think.
If the question is like if the null space of a matrix is one span, like some 722 minus 1, then
Yes.
what is the row space of the matrix? He asked the span for that. The span of the row space.
No, then in that case, no. So it will be difficult. It will be difficult.
Okay, so that was a question from the question paper. That's right.
So in that case, see how we'll get here. So span is given, right?
Span of the null space is given. Yeah.
Span of the null space is given. So let's say that vector is 1, 2, okay, 3. Okay, let's say this is only given. Span of this.
Yes.
Sample. Suppose this is given. So that means what? It is a span. So can we guess that what is the, so it would be difficult. Still, let's see that how it could be. The finding the row space. So let's see how it would be. So suppose this span we have. So that means what is the equation representing? This represent a line, right? So this represent a line, right? Null space is right. This represent a line.
Yes.
So this would be what? This that means here this is the solution of a particular, let's say there, so this there would, that means here this is Z and Z belongs to R. This is the null space going to be. If a span is given, that means null space is going to be this one. This is means here Z, 2Z and 3Z, okay, and Z belongs to R. So that means what is the relation now? Can we get a relation between X, Y, and Z? This is X, this is Y, this is Z, here capital Z. This tells you X is equal to 3 times, what is this? Capital X is equal to 3 times Z. Small z. So 3x is equal to 3 small z means capital Z. So 3x is equal to this. This is one equation. Second equation is 2z is equal to, I will tell you, okay, let me calculate. This y is equal to 2 small z. So this y by 2 is equal to z. 3y by 2 is equal to 3z is equal to capital Z. So 3y is equal to 2z. So one equation we got here, which is 3x is equal to z, and second equation we got 3y is equal to 2z. That means null space is what? Null space is the solution of this system of linear equation. 3x is equal to z and 3y is equal to 2z. So from here you will get the matrix form. If you change this, what will get here? 3, 0, minus 1. So here it would be, you can write here that is equal to 0 minus 1. And the second equation is 0, 3, and -2. And this is 0, 0, 0. X, Y, Z is equal to 0, 0, 0. This is right. This is going to be correct one, right? From here, this is the 1, 1, right? 1, 1 thing.
Oh, thank you.
So the row space is going to be this one, these two. I don't know. I just quickly calculated, but are you getting this? This is how I follow, but I
Find out
don't
the
know.
relationship, and then from that you find out. Okay.
Going to the relationship, finding that null space in the in the system of equation form, then back to the matrix form and find the matrix, and this is going to be the basis.
Suppose if you are given the matrix itself, and then you want to find out the orthogonal to its column space, how do you do it?
Orthogonal to column. Matrix is given. Sorry. What is
matrix
that?
Is given, and matrix is given, say 1, 1, 2, 2, and then you have to find out the orthogonal to its column space of that matrix.
1, 1, 2, 2. Okay. I want to find the orthogonal
to
of
its column space of this matrix.
A column space of this and orthogonal of it, right? That is what you are.
Yeah.
Okay, so this is, what is there is a relation. The column space and orthogonal is, what is that? This is going to be no issues. Okay, so this could be, first find the column space. What is going to be column basis of the column space? This is going to be what? The both itself. This is the basis. This is the basis of this column space is what? 1, 2 and 2, 2 itself. Because if we do the reduced row echelon form, this is 1, 2, and this is 0, -2 you will get. That means this column here is actually going to be basis, and here is not. Here is also going to be pivot. So this column is also going to be basis. So this is going to be your basis. And now find the orthogonal of this. What is the orthogonal of this? Orthogonal is going to be what in this case? The 0 is only. Because what is going to be orthogonal of these two?
How 0?
Just a second. Yeah. 0, 0. 0 means 0, 0 vector only. So what is going to be orthogonal of these two separately? What is orthogonal of this one and this one? Which vector is going to be orthogonal to these two? How we'll get this? Let's say xy. Okay. Let's say xy is the orthogonal. Okay. Vector which is orthogonal to these two. That means here do the dot product with xy. That means you are getting 0, 0. And also with the second one, dot product is going to be 0, 0. Correct?
Okay, got it.
That's the meaning here. And if you solve this system,
you'll
get x is equal to 0, y is equal to 0 only. Correct?
Yeah, got it.
So actually, what is the meaning here? No, column of this is nothing but the perpendicular of this is the null space of the matrix. This is the lesson. You can see I'm actually finding the null of this. Correct? Here, if you see here, what is happening? Column space and orthogonal is nothing but the null space of the same matrix. That is the relation. You can also verify whatever we are doing here.
So always the orthogonal is the null space.
Yes. Orthogonal of the column
matrix, right, sir?
Sorry?
For the full rank matrix, it will always be null space.
Yeah, so 0, 0 is going to be the null space.
Yeah. Only null space is going to be orthogonal. If it's not full rank, then there will be something.
Yes, so something. Yes, correct. Okay, so actually these all what I'm saying, I see what I did here. I in starting I don't know this relation was there, but yeah, I said right there is a relation with the something, but I forgot that. So what I did, I just from back itself. What I did, I found the null. Sorry, for the first find the basis. Sorry, of the column. Yeah, basis of the column, Then I started finding the perpendicular of each vector. That is what I did. And then I got the relation, yeah, column perpendicular of the column space is nothing but the null space of the same matrix. So this is the relation actually. So whenever so what I mean to explain you that whenever some problem is asked, if you know the definition, try to start from there. Yeah, it is, we are at the free time. That's why we are able to do. There is a constraint of the time. I know it. But if you have time with, in that constraint, so, and you don't know what is the, how to get, so use the definition itself, because mathematics is already built from the definition and step by step. So do the stepwise and reach to the final thing. That is what I want to explain.
Sir?
Yes.
Column space is orthogonal to its left null space, right?
Yeah, no, left null space. No. Column space is orthogonal to no. If it is such thing, then I have to check something. I have already seen these all, whatever you ask. But yeah, I think something is not same. I have to check it. I already know. We can verify with some simple example. Okay. I think something is there.
Yes, sir. Row space is perpendicular to null space, and column space is perpendicular to left null space.
Column space is perpendicular to, yeah, okay. Row space is perpendicular to null space. Null space. Yes. Row space is perpendicular to null space, and column space is perpendicular to the left null space. Correct. Yes. Correct. You can also, that is what happening here. If you see that, what is that? Left null space is what? Transpose we are doing, right? Transpose and then finding the null space. And if you see, column space is exactly the same, means taking the dot product with this one. See, this is what? If you do to transpose of this matrix, this will be 1 2, and this is 2 2, and find the null space is what? This 1 2 dot with xy. See here the same. Correct. Column space is the perpendicular thing of the left null. Yes. And row space is the perpendicular of null space. Yes. Okay, that's all.
Suppose if AV is equal to B is given, A is the matrix, and then V and B are vectors. Yeah.
Now can we skip? Now can we stop now already? It's already 3 hour session, so it's already night also. Yeah, many things are there. Even that's fine. I think we'll see in the next session.
Yes, sir. Thank you, sir. Good night, sir.
Yeah, thanks.
Thank you, sir.
Thank you, sir.
Good night to all of you.